So welcome to my dear student. So today we are going to learn few topics on solid state physics. So the first topic we are going to learn is the knowledge about electrical conductivity. Okay, so we know the current density. That means how the electricity is getting produced. So in conductor there will be a free electron. So when there will be a flow of a movement of free electron, so this will cause the current. Okay, so then in the unit cross section, how much electron will flow in unit time, that will be denoted as the current density. Okay, so that we know. Say this is a metal piece. Okay, so electron from one end to another end, it will travel. That may be some electric field or some potential or something if it is applied. So the current density J, we know already, it is defined by it's a negative sign. It indicates the charge of the negative charge of the electron. So this is the number of electron, and this is the charge of each electron into the velocity, the drift velocity. Okay, so this is the expression for current density. Okay, now if there is some external electric field is applied, okay, so the electron will experience some force. Okay, some electromotive force. So that is given by minus E into capital E. So small e is the charge of electron, okay, and E is the electric field strength. Okay, so it's a force. So as per the Newton's second law, so this force is equal to mass into acceleration. So if there is a force, the particle will experience some acceleration. So this is the equation. Okay, now from here we can find out the acceleration is equal to minus E into E divided by m. This is the acceleration. So what is the acceleration? Acceleration is nothing but the change of velocity with respect to time. So here the velocity already we defined as the drift velocity, and let us take the time as tau, which is called relaxation time. That means the electron, the mean time, so that the electron is travel from one end to another end of the metal piece, what we are showing here. Okay, so now from here we can find out the if we find out the expression for drift velocity. So this will be Vd is equal to minus E capital E into the relaxation time by the mass of the electron. So this Vd, if I replace here, it will come, because it is minus, so minus minus it will be cancelled out. So it will be n E square tau by m. Okay, this is the formula for the current density. And from the Ohm's law, already we studied in our 12th standard. So this current density is nothing but the electrical conductivity into electrical conductivity into the electric field. This is my current density. Say here one term I missed, that is E. Okay. So now from this equation, this electric field is cancelled out from the both sides, and the electrical conductivity sigma, which is now as N square tau by M. Okay. Now we will try to find out. Now we will try to find out this value of the tau, this relaxation time. So this can be obtained from the equation. This can be obtained from the equation because where time is related, that means we have to consider the velocity, which is the threshold velocity of the electron, and the kinetic energy of it, it will be half m v. This is the thermal velocity, sorry, not threshold, the thermal velocity, because when the temperature is the metal temperature is increased, so normally the electron will gain the energy. So that energy, it is given by Boltzmann theory. So that is 3 by 2 into k. This is the small k. This is the Boltzmann constant into the absolute temperature. Okay. So from here we can find out the VTH, the thermal velocity of the electron, which is nothing but from this expression root over 2 to cancel. So this will be 3 kT by m. 3 kT by m. Okay. Now this thermal velocity is nothing but the mean path that the electron is traveling, because it will collide with each other and then it will reach another end, and it will be that electron will flow through the external circuit. Okay. So this mean path, so velocity is distance by time. Okay. So the mean path I am writing as lambda. Okay. So this mean path divided by the mean time. So this is my VTH. So from here, if we find out the lambda, tau, so this will be, how much it will be? It will be root over so if I find out the lambda, so this will be tau, so this will be lambda divided by root over 3 kT by m. Okay, 3 kT by m. So now the lambda could be replaced here. This lambda could be replaced here. This tau could be replaced here. So this is n into square of the electron charge, and here it is lambda, and this root m, it will be going top, and downside 1 m in denominator, and root over 3 k into t. So now final equation, it will be turned as n e square lambda divided by root over 3 kT m. 3 kT m. So all other terms, the n, e square, lambda, if for a particular circuit or particular conductor, this n, particular volume of conductor, okay, if that is considered with some external circuit also, so this n, e square, lambda, k, m all are constant, okay. So now here we can write the lambda, the electrical conductivity is proportional to the square root of the absolute temperature of the metal. So this is the expression, for electrical conductivity, okay. Thank you so much. Thanks for your watching.